Hello students, welcome again to our next lecture for oscillations. In this lecture, I am going to discuss again some terms about the energy of a particle performing S.H.M. In the last period, we have discussed about how to find the kinetic energy, how to find the potential energy for a particle performing linear S.H.M, and then we have find the total energy for a particle performing linear S.H.M. Here now I am going to explain some special cases for the particle performing linear S.H.M, that the special cases related to energy. So what is the first case here? At mean position. What is the total energy, kinetic energy and potential energy at mean position? Now we know at the mean position always the particle has the displacement x is equal to 0. So what is the formula for kinetic energy? That is half m omega square a square minus x square. When we put the value of x is equal to 0, we get kinetic energy is equal to half m omega square a square. Now half m omega square a square is nothing but the total energy. So we can say at mean position the kinetic energy is maximum and it is equal to the total energy. And at mean position we know the formula for potential energy is half m omega square x square. When we put the value x is equal to 0, we get the potential energy is 0. Thus at mean position the potential energy is that 0 and the kinetic energy is maximum. Actually we know that at mean position the velocity is maximum, that is V max is equal to a omega, and that's why the kinetic energy is also maximum at the mean position and that is equal to total energy, and the potential energy is 0. Now what is at the extreme position? At both the extreme position, positive extreme and negative extreme position, we can say the values of this displacement are plus a and minus a. Here at this point m, the displacement is equal to we take plus a, and at this point we take minus a. So we can put the values of displacement at extreme position, that are x is equal to plus minus a. So when we put that value here, we get the potential energy is equal to half m omega square a square, because we know x is equal to a. Is that again it is equal to the total energy. So we can say the total energy is equal to the potential energy. Now in the formula of kinetic energy is equal to half m omega square a square minus x square. When we put the value of x is equal to a here, we get a square minus a square in bracket and we get the value 0. So I can say that the kinetic energy is 0 here, where at the extreme position, at both the extreme position, the kinetic energy becomes 0. As the kinetic energy becomes 0 there, the particle reverses the direction of motion. Is that? So the kinetic energy is maximum at mean position and 0 at two extreme position. The potential energy is maximum at extreme position and minimum at the mean position. And the total energy, that is half m omega square a square, we have discussed earlier, that is always constant. Means when the particle performing linear simple harmonic motion at any position, at mean position, at two extreme position, or at any mean point, the total energy always remains constant, and so that we can say that the total energy in linear simple harmonic motion is conserved. It is constant. It only changes its forms. The total energy divides some part into kinetic and some part into potential. That we can explain with the help of graph. In your textbook there is the graph is also given. Explain the variation of kinetic energy and potential energy in linear S.H.M with the help of graph. Sometimes there will be the question in board exam, or for the when the question is for 5 mark, total energyचा क्वेश्चन जेव्हा तुमचा 5 मार्काचा असेल तेव्हा त्याच्यामध्ये तुम्हाला ग्राफिकल रिप्रेझेंटेशन डिस्कस करा असं विचारलेलं असेल. इन दॅट केस वी हॅव टू ड्रॉ दिस ग्राफ. सो सी हियर हाऊ वी ड्रॉ द ग्राफ. On y axis we take the energy and on x axis we take the displacement. Suppose at the origin we consider again the displacement is 0. This is the plus a, that is the maximum displacement on right hand side on x-axis, and towards the left of the origin, suppose this is the point minus a, that is the maximum displacement amplitude at the negative extreme position. So this is the path of linear S.H.M. is that at mean position, see here this curve represents the graph of kinetic energy. At mean position the kinetic energy is maximum, that is equal to total energy. समजते? This dotted line represent the total energy and it is always constant. Total energy ची value काय राहील नेहमी constant. So we get the graph that is parallel to x-axis at any displacement, and the kinetic energy is maximum at mean position and minimum at extreme position. म्हणून हा ग्राफ बघा असा डिक्रीज होतोय. समजते? Now this curve represent the potential energy. Is that the potential energy is minimum at the mean position and maximum, that is equal to total energy, at the extreme position. Here at this point when the amplitude is divided by the square root 2, is that we can say the kinetic energy and potential energy graph cross to each other. That is the value of kinetic energy and potential energy are equal at this point a by root 2. That is given in your book. We will discuss that point also. Now in the special cases, here we have discussed two cases, that is at mean position and at extreme position. Now we see again 2 points. The third point, we say that when the kinetic energy is equal to potential energy. What we discuss in this third point, we say that if kinetic energy is equal to potential energy. Now what is the formula for kinetic energy? Half m omega square, is that a square minus x square. What is the formula for potential energy? Half k x square or half m omega square x square. Omega square x square. Here m omega square cancel होते. When we multiply this half, we get 1 half a square is equal to half x square minus इकडे जर घेतला तर plus होईल. Half x square plus half x square, we get x square. So we get x is equal to here plus minus a upon root 2. म्हणजे बघा x is equal to plus a by root 2. इथे kinetic energy is equal to potential energy आहे. x is equal to minus a by root 2 या distance वर. समजतं? Again the kinetic energy is equal to potential energy. This is very important for the objectives. Now again we discuss one special case, that what will be the value of kinetic energy and potential energy at the half of amplitude. Is that means the displacement x is equal to a by 2. जेव्हा mean position आणि extreme positionच्या exact मध्ये असेल particle, म्हणजे बघा amplitudeच्या half असेल displacement, x is equal to a by 2. Again we can see here plus minus a by 2 या साइडला किंवा या साइडला. In that case we calculate first the potential energy. We know the formula for potential energy is half m omega square is x square or half k x square. When we put the value of k x is equal to a by 2, we get here a square by 4. So I can write half k a square upon 4. Now half k a square is nothing but the total energy, and so I can say here E by 4 means the potential energy is the 1/4 of total energy. Is that? Then what will be the kinetic energy? Here kinetic energy काय असेल? Is that? See here, for that we take some example. Suppose the total energy is equal to 100 joule. जर total energy 100 joule आहे, समजते? मग या डिस्टन्सला a by 2 half of amplitude ला potential energy काय असेल? 100 by 4, that is equal to 25 joule. मग total energy मधले 25 joule potential energy आहे. So what will be the kinetic energy then? That is equal to 75 joule. म्हणजेच आपण म्हणू शकतो कायनेटिक एनर्जी इज 3 times पोटेन्शियल एनर्जी. इज दॅट ॲट हाफ ऑफ द ॲम्प्लिट्यूड. इकडे जर मी हा पॉईंट घेतला, इथे म्हटलं a/2. इकडे जर हा पॉईंट घेतला, इथे म्हटलं x = a/2. या पॉईंटला मला काय मिळेल? कायनेटिक एनर्जी इज 3 times द पोटेन्शियल एनर्जी. पोटेन्शियल एनर्जी इज 1/4 ऑफ द total energy, or again we can say that the kinetic energy is 3/4 of the total energy. Kinetic energy is the 3/4 of total energy. Thus we have discussed the different cases of total energy and the graph. Thank you.